Oh, this things. Today is oh, sorry about this. Today is the 15th of March 2026. The time now is 3:31. Time now is 3:31. 3:31 p.m. 3:32 p.m. So this video is literally on a few things. Let's get clarification done. So we can get into the code of Mmuko REST. But let's see what it does. So basically a ringboot system. This is article here. Cybernetics operating architecture module. Basically, the problem with traditional boot systems, most operating systems treat it as an engineering problem. Initialize hardware, load a kernel, run Linux. Mmuko doesn't want to run anything. Mmuko, the system doesn't know who it is. It doesn't adapt. It doesn't just start. It just starts. Mmuko is M for Mike, F for Mike, F for Umbrella, K for Kilo of Oscar. Is an operating system that calibrates itself during startup using behavior profiles, topology, memory, geometry, and self-stabilizing stabilization. It knows where it comes from. It's a line. You get a line on the space and time of the operating system, but it's a humorous operating system. It's a Mmuko is a neurodivergent. M for Mike, U for Umbrella, K for Kilo of Oscar. Is a neurodivergent operating system. It works because on the worst day your computer boots up, because it calibrates itself to boot up on the worst day. The day you really need it, the day you trust to break, and that's what I'm saying. So Mmuko is common is topological bits called qubits. Every byte is an A-big compass ring. North, east, southwest, from 0. These are called qubits. Qubits is a model of topology, but they are polar. They are like a circle. They have a direction, like a magnetic. It's basically a magnetic quantum computers. Value 0, 1. Each qubit has 0, 1. North, northeast, east, southeast, south, southwest, west, northwest. Up, down, charm, strange, left, right. As it states, angular momentum pi over 4 to 2 pi, and that's rotation and entanglement of mirror pairs of the system. It's computation model because it's memory becomes topological, not linear. It's topological memory. It's a ring boot system. So that's the definition of system. Now, you have a cap profile. Now, cap profile is what you use to store the. So you can have your profile. If your profile changes, it's still to load that state. Here are two trainers. But let's go into the code base now. No more talk. And this is how you boot it. Mmuko boot, default cap, research cap, secure the cap. Let's try and boot it here. CD Mmuko boot. CD Mmuko boot cap. ls. Now you get a cap profile account. This profile account, the standard process is calibration for that system on that day. Think of the cap files as they get updated frequently because the game doesn't calibrate itself. And the calibration of the system, because the current system, can create a whole profile for like being under the sea. Sea or cap, under the ocean, and you can still get an instant connection or something based on how you calibrated it. A system that can give you internet on the surface, if you set another technology that way, that's the beauty of the framework, this is a cap file. This is code profile of cap, but this is OB Nexus. So user profile, but you're gonna have a system of the cap file. So how does the cap files work? The cap files, calibration files, work by having Alexa and a parser, and you're gonna have an AST. The qubits are topological, and you basically you're taking the qubits, C for Charlie, U for umbrella, B for Viper, B for byte, I for indigo, T for tango, I for Sarah, Q bytes, and you're having the qubit have a fingerprint and a signature, and they are, written over the qubit. They are entangled to say via the qubit. For example, you're gonna have north entangled to east, northeast or south to west, northwest, etc. etc. But after the entanglement is done, the profile of the calibration files can orientate a resolution, and it's a staleness system. It doesn't dry out. It doesn't run out of time doing anything. It knows that if you place me here in this desert, I can give you internet connection. Desert I can, I can provide you internet connection because I've been calibrated in a certain way via a profile to do it. So this, what I was saying to you, you have Alexa, browser, and AST. So you have a lexical analyzer, a parser which is a program file like Python parser of the cab files, C parser of the cab files, and that program creates a fingerprint for the cab files, and the cab files can give you associative, beautiful, associative, can associate it. So it's a load system, not a raw system. It loads files. So Mmuko boot just only works on road. It doesn't learn anything because to run means you have to recalibrate, and it's just calibrated. It's a DAO. So it goes through itself. So that's how it works. It's an AST fingerprint. You get an AST fingerprint, signature of AST. So you have the beauty of this, it takes AST fingerprint and dump it, create a hex dump into C or Python, or Node. It doesn't matter how it's calibrated, can have an abstract signature from a definition, which I'll have to show later, over via the cab files. That's the next step here. So if I run Mmuko boot.sh profile account, yeah, this is now run. From phrase 0, the vacuum initial medium, the ring boots, phase 1, the reboot, and resolving the batch. Basically, it calibrated for today. The system just booted again, recalibrated for today, and today's a new day. So the system recalibrates based on the CAD files. I can get into the question, I can get into it based on how the frame of reference of the computation system via ontological system. The system knows what it's doing. It knows to calibrate before it even starts. But it has no issues at the moment. Byte order. So you have a gravity medium of a lepton, a muon, and a deep, which is a twelve. You know, they calibrate it based on gravity too. It takes into account things that can weaken the system before the system starts. The beauty of the Mmuko boot system, it's literally gonna boot because it's either you boot this one day or you boot another day. It's gonna be bootable. So let me show you what I mean. So if I come here and show these files here, these images are used to it's chapter 1 origins, chapter 2 pillars, representing the Mmuko B sequences. I don't know what to do, but these are all energy system. It's gonna be in the code base. I can give you consensus. This is beautiful, guys. This is a constitutional model, but it's beautiful, guys. So you have you by sites. Yes, no lines. You have read me here. Okay. So you're gonna have the next phases of the calibration, which is basically the AST fingerprint, and which will basically determine the um uh uh for for self architecture compliance. Because if you want to run code, you have to have an AST that can like for Windows for the target platform via an architecture. The other example. Where's the Mmuko? Sorry, guys. I'm trying to find something here. Is with me? Yes. 8 qubit spins. Uh. Yeah. So you're gonna have the secret code. Let me go to the system. So I'll show you here. So you're gonna have the creator of the system. nsigii yes. nsigii no. nsigii maybe. This is what I'm saying. Uh. The goals to have them resolved via a branching system. But to respect the kind of spin state of qubit systems, of a computer. So she's saying build a sage and so this is gonna work on the I don't have VM. Did I install VMware VirtualBox? Is the VirtualBox installed? Look, VirtualBox is not installed, so it's not gonna work without VirtualBox. So the next steps are via the dollar slash to have AST communication, AST fingerprint uh, as a codec, as a single, can be verified via the hex dump of the codec. The hex dump will allow you to verify the byte order via the AST, but it should be the same fingerprint. But the tool is to check the Python can take the AST, but this is a type of problem. But the hex dump is isomorphic and topological. So when I've done that system, it will start to boot, and it's still what I'm saying. It will start to work as intended. I'm saying, but it's already working as intended now, and it's beautiful. So this is Mmuko drift. So we're gonna go to cd Mmuko drift Python main. So Python main will go. Oh, this is go main no go. Go. Hmm. So my Go application started. Oh my god. Python. This should be basically these are two servers that work together. I didn't download. Go model download. Let's just spin up now. Yes, yes, yes. So this is a drift system. Foster couple API sticks objects. Drift. So shifting, drifting. Am I? So this is a drift system, but the system uses a drift into models kind of space. What's my point? I can't remember my point. So you have to understand my camera is being used, so it will not be drifting. I don't have two computers, so I can't just take them out of the network and start using them together, but my computers are missing here. So local host API states. This is states of the data transmission, order, chaos. Yeah, so I can't really put that there. But it goes to have system recognize itself, but so the Mmuko sequence here, Mmuko cam, hollering. So basically this is the trident here. So this is how the system works. This is how nsigii works. So nsigii is a human protocol. It gives people a shutter. The trident line, you have a signal. Because it's the internet. You know what I'm saying? Come on. Protocol verify, because the trident aligns. The trident already aligned. If we try to align it, I'm gonna try to find. File server. I don't have Oracle VM, so I need to download a VMware workstation. VMware workstation, bro. VM. Let me use this is free now, and I have to try to do art on my operating system. So how we are doing this now? So this is a file server. Let me just find. So these are files here. Oh no, failed because of this fucking thing. So this is signal. You have this is signal. Wait, this Gemini Power. Yeah, no, I don't like it. Wait, 1 second, guys. But it's gonna be. So you're gonna have they look like this, but you're gonna have other ones too. I just can't find. Show this one. So this is trident aligning. Let me just remove my camera from here. So I have to remove my camera from here, guys. I have to remove my camera from here. You guys can see my screen even all this time. So let me just remove my camera from here. This is a bad video already, but camera. Oh no. So I'm saying to you, basically, it's the only one for that camera, man. Just try. I don't know what I'm doing no more. I'm trying to use this video to update the system, but you know, it's not coherent enough to do it. So the hexadump is the interface of the AST basically. Let's go run something else. Let's run something else. Let's run something else. Oh, Python server.py. Basically, this should be the server.py, the server application. Server. What gives? Um, it's- it's- I don't know, I'm doing no more. But you know, I'm lost at my. This is literally images. My God, it's basically YouTube images here, really bits. It's, include between 16 version. Check some flag. Oh, this is assembly code. The bootsector is the byte of Coding and assembly language. What's the pattern? Bootsector 888. Solution bootsector of an image. I think this one will show you guys. On a ring. Saying it's really cosine x. It's a little book of, you know, I don't even know how to get back into it. So, 1, 2, cosine is sine x becomes cosine. Cosine x, cosine, so sine, 1 sine 1 cosine x. With my other one, guys, it's just a bit of review I'm doing anyway. So, this is the image I had here. This is a dog. C sharp language. I'm still assembly, guys. Assembly should elaborate two sectors. Start each one. So that's video stop, okay?